everyone, this is Mel. Today let's go through chapter 3 about quadratic. So the general expression of the quadratic is y equal to ax squared plus bx plus c, where a and b and c are all constant. Okay, and the method of factorizing. So for this quadratic or general polynomial, when we want to factorize something, so we want, instead of the plus sign, we have the multiplication between each term. So in this case, we have a multiplication between the constant 9, the x squared, and x plus 3. So there's no plus between each term, and the plus can only be inside, or the minus can be only inside the single term. Okay, so 9x cubed plus 27x squared. So commonly, we take out the 9x squared because that's the common term in both. So after we taking the 9x squared out, the first term is left with x. The second term is left with x plus 3. Okay, so taking out common factor. The second method we can use is grouping. So grouping. If we have this long polynomial, then so it might not be easy to see, but we group the first two terms and group the last two terms with a bracket. And if we take the minus out, then it should be plus 12. And then in this term, we see it's a x squared. So we can take x squared out, and then it left with x plus 4. And then we can take a 3 out, and then it becomes 3 times x plus 4. So luckily, we have x plus 4 in both terms, and we can again take it out, and left with x squared and minus 3. So this is called grouping terms. So we group two terms and try to find a common term between these two groups. Okay, difference of two squares. So this is quite important formula. X squared minus a squared is equal to x plus a times x minus a. So for example, we have, this is actually 4x squared minus 7 squared. And according to the formula, we get this. Okay, factorizing quadratic expressions. So we can use a method like this. So the constant in front of the x squared is 1. So only can be 1 times 1 to be 1. And the constant is negative 8. So we try to make an a and a b, which a times b to be negative 8, and a plus b to be the factor of the middle term, 2. And with trying, you can try, so a and b are factor of negative 8. You can try 1 and negative 8, which you do not get 2. And after trying multiple examples, you will see so it's actually 4 and minus 2. So 4 times minus 2 is negative 8, and 4 plus negative 2 is 2. So we do a 4 and a negative 2, and we cross that, which becomes x plus 4 and x minus 2, which is exactly over here. So the same as this one. We have 1 and 6, or you can try 2 and 3. For negative 15, we have 5 and negative 3. And because you want to make a negative 13, if you times it together, then it should be negative 18 plus 5, which is negative 13. So it's becoming x minus 3 and 6x plus 5. So in this case, if the constant in front of the x squared is not 1, like in the previous case, then we need to introduce 2 new variables, which is a factor of the 6. You can call it C and D. So we need to satisfy first so this place should be replaced by C, this should be replaced by D. And for the negative 15, which we introduced earlier, the A and B. So you have a factor of A and a factor of B, which is from the negative 15. And you need to make C times B plus D times A equal to the middle term, so negative 13. And you need to make sure that C and D are factors of the leading term constant, and A and B are factors of the constant negative 15. Okay. Let's move on. So the graph of a quadratic function may be sketched by first expressing the rule in turning point form, like this. So we have a constant a in front of the x, and x minus h, and plus k. So this h and k becomes our turning point. So in here, the 1 and 3 actually represents h and k. The graph can then be obtained from the graph y equal to ax squared. So normally, the turning point is on the 0, 0, because when x is equal to 0, y is equal to 0. But however, if in this form, when we have the turning point, x is equal to 1, and then y is equal to 3, because this term goes to 0, and y is left with 3. So the turning point, 0, 0, now becomes 1, 3. So you see in this graph, before the turning point, when x is negative, then the graph is decreasing. And after the turning point, when x is equal to 0, after the turning point, x is positive. And that means y is also positive in this case. So that's actually because after the x under the square, so when x is equal to 0, so this red circle, this position is equal to 0, and that causes the turning point. Same over here. So under the square, we have x minus 1. So if this thing is equal to 0, that actually represents the turning point. X is 1. So we only need so whatever this is, plus k, we only need this part to equal to be 0, And if it's 0, which means x is equal to h, and this point is the turning point. Because you can think of it this way. So because if x minus h is smaller than 0, which corresponds to the red part of the graph, it's decreasing. If x plus h is greater than 0, and that corresponds to the blue part, which the graph is increasing. So to find the turning point, we need the same between them, which is x minus h is equal to 0. So this point is before it's going up and after it's right to go down. So that's when x is equal to h. And when x is equal to h, we have y equal to 0 plus k, which we have y equal to k. And that's why the turning point, is also always h, k. So to find the turning point, we only need to find when x minus h is 0. Okay. The quadratic equation, when it's equal to 0, it may be solved by factorizing or completing the square. So completing the square means we want to take the a out and becomes something like, and depending on this x squared and this middle term, we need to find a part of the c over a to make the thing inside the bracket becomes a square. So let's introduce a new term, and you can have some constant left, for example, e. So you want to make this thing into a square. Let's give an example. For example, x squared plus 2x plus 3 is equal to 0. So we want to complete the square. We take the a out, which is 1. It doesn't matter. And we want something to make this first two term to be a x plus 1 squared, which we need 1. And then it's left with 2. So then it becomes x plus 1 squared plus 2 is equal to 0. So that's like what I was saying over here. So we have the plus 3 as this part because we want to make it be a complete square with minus d. Then we have plus 1 over here. So we can make x plus 1 squared to be a completed square. Then because we have a plus 3 and we use plus 1, so we left with plus 2. And this e over here represents the plus 2 over here. And a is equal to 1. So that's called completing the square. Okay, the quadratic formula is very important. So in any case, you can solve it using this formula to solve this equation. So you can, if completing a square is very difficult, then you can directly use the quadratic formula. The following steps can be used to sketch the graph of quadratic function in a polynomial. So how do we want to sketch this one? If a is greater than 0, the function has a minimum value. And that means, just like this case, it has a minimum value, which is just the turning point. So it means the open is facing upwards, like this. So it's facing upwards. And that allows us to have a minimum value when a is greater than 0. If a is smaller than 0, then we probably have something like this. And when a is smaller than 0, the open is facing downwards, and it have a maximum value. The value of c gives the y-axis intercept, because when we want to find the y-axis intercept, we need to set x is equal to 0, and that means y is equal to 0 plus c. So the first two terms become 0, and the c gives the y-axis intercept. And the axis of symmetry. So if we have a graph like this, and this axis is called the axis of symmetry, and it's defined as y equal to -b over 2a. The x-axis intercept are determined by solving this equation. So the left-hand side is equal to y, and when y is equal to 0, that means we are solving the x-intercept. And to solve this, we can use the method we talked about earlier, factorizing, completing the square, and just quadratic formula. And because of the plus and minus here, you should be able to get, in this case, 2 solutions. The number of solutions of a quadratic equation can be found by discriminant. So this delta is defined as b squared minus 4ac. And if, which is this delta, is the same as here. So why do we normally have 2 solutions? It's because the plus and minus sign over here. And if the b squared minus 2ac is equal to 0, then the plus and minus does not work. So the solution directly become x is equal to -b onto a, which is just the turning point, because this is actually the equation of the symmetry, and the equation of the symmetry is on the turning point. Okay, that's the case when the determinant is equal to 0. That's the case when we have only one solution. So if the delta is equal to 0, only have one solution. If it's smaller than 0, then have no real solution. So note that it's no real solution. So later on you will learn complex solutions. And normally when delta is greater than 0, it have 2 distinct solutions. Because if this part is greater than 0, then this plus and minus sign take an effect on the number of solutions. You can have a +1 and a -1, so that's 2 solutions. Okay. So whether or not you have these two, whether it's greater than 0 or equal to 0, it depends on how many. So let's talk about graph. If you have 2, then maybe look like this. So you have 2 x-axis intercept. If you only have 1, then the x-axis only touches your turning point. Or it may look like this, only touch the turning point. When it's smaller than 0, then it do not touch. It can be like this or like this. So it does not touch the x-axis. To find a quadratic rule to fit given points, choose the appropriate form. So these are 3 forms. This one is the most common form, but you need 3 coordinates. So you need 3 points to determine the whole function, because there are 3 unknown variables. If you have n unknown variables, then you need n equations or n points to solve it. So we need 3 points here because we have 3 unknown variables. And this form is the turning point form, which can be used if the coordinates of the turning point and one other point is known. So if we know the turning point, we know the h, k. So we know these 2 variables. And if we know another point, then we should be able to get the value of a. And this form, which is the intercept form. So if 2 x-axis intercept is known, for example, E and M, and F and N. So these 2 points are known, then we know the E, we know the F, and with another point, with another coordinate, we should get the value of A. So it's depending on what kind of points do you know. If you know the intercept, then use this one. If you know the turning point, then use this one. If you know 3 points, then you can use this one. Okay, that's it for today. Thanks for listening.